In this video, I'd like to talk about interpreting exponential expressions with word problems. And in these problems, we're going to be given some algebraic exponential expression, some formula, and we need to determine what the different numbers mean in that formula or what they represent. So for this first problem, the expression 4 multiplied by 3 raised to the t power gives the number of ducks living in Anoop's pond T years after he built it. So we need to determine what does 4 represent in this expression. And we're going to be given multiple choice here. Now, one way to approach these problems is to just make a table and see if we can figure out the patterns. So let's write that down. We can make a table. So let me draw that very quickly. And we know that we have essentially two different variables. We have t, that's our independent variable, that's the time. And then our second variable, which we don't have a letter for here, is the number of ducks. So let me just write that out in words. So we're looking at the number of ducks here. And when t is equal to 0, we're just going to plug these t values into the formula. So let's write that down here. So when t is 0, we have 4 multiplied by 3 raised to the 0 power. And we know that anything to the 0 power is just 1. So this is 4 multiplied by 1, or just 4. So when time is 0, or when we're talking about 0 years after the pond was built, there are 4 ducks in the pond. So it looks like 4 is the starting number of ducks. But let's just keep going to confirm that that is what 4 represents. So when t is equal to 1, let's now plug that into the equation here. And actually, let me change colors so that we can tell the difference. So when t is 1, we'll have 4 multiplied by 3 to the first power. And 4 times 3, that's 12. So for 1 year after the pond was built, we now have 12 ducks. Let's look at when t is 2. We have 4 multiplied by 3 squared now. And 3 squared, that's 9. 9 times 4 is 36. So after 2 years, or 2 years after building the pond, they're now up to 36 ducks. And we can continue. If we did t is equal to 3, we'd have 4 times 3 to the third, 4 times 27, which would be 108, and so on. So when we just have t for our number of years since it was built, we would just plug that into the expression 4 times 3 to the t. Now, what we can notice is that, again, for that starting amount, there were just 4 ducks. So that actually answers this question. So what does the 4 represent in this expression? That is B here. Since there were 4 ducks living in Anoop's pond when he first built it. So that makes sense. Now, if the question asks us, what does the 3 represent? What we can notice is that every single year, the amount of ducks is multiplied by 3. And so 3, in this case, that is our growth factor. That is the amount we're multiplying by every year. So if we were trying to figure out what 3 represented, then the number of ducks living in the pond is multiplied by 3 every year. And remember for these exponential expressions that the number that doesn't have t in it, we can call that a. That is our starting amount, so 4 in this case. And then these exponential expressions will be multiplied by b raised to the t power, where b, that's our growth rate, or it could be our decay rate, and t is the variable for time. And understanding this general pattern will help answer the questions much quicker. So like I said, a, that is our starting amount. And in our case, you can see that's 4. And b, that's our growth rate. So in this case, our growth rate is 3. Every year, the amount of ducks multiplies by 3. And of course, like I mentioned, t is just time for these problems. It can be something else, But usually when we're dealing with realized situations, these exponential word problems are going to be dealing with a variable of time.